How are you, my friends? In this video, I'm presenting lecture number 12 of Pre-Calculus course, Applications of Trigonometry of Right Triangles. Please, you can review lecture 11 on Trigonometry of Right Triangles, and it is related to lecture number 12. Now, at the end of this lecture number 12, you can find some old exams questions to practice on both lectures. So here we see some applications of right triangles. Let me just define something here. What do you mean by line of sight? Line of sight is the line from the eye of an observer to an object. So either a person can look up, see, it's looking up, and this angle here, we call it angle of elevation between the horizontal line and the line of sight. If the person is looking down to a point, the horizontal line and the line of sight, see the line of sight going down, looking down, then we call this angle of depression. So just differentiate between angle of elevation, angle of depression. So this angle here is not the angle of depression. This one is the angle between the horizontal and the line of sight. Let's see some questions to apply on this angles. Example number 7. This is a continuation of lecture 11, by the way. From a point on the ground 115 meters from the base of a tree, the angle of elevation is 60 degrees. Find the height of the tree. In these questions, in the applications, you have to read it, please, one time or two times carefully, understand it, and then make a little sketch. I advise you to do that. And then from there, you can form a right triangle, and then you can do the question and find the required part. So this is this sketch now. So you can just imagine a tree. You can just put any tree you like. And then from a point, we have 115 meters from the base of the tree. So all this distance from the base of a tree to this point is 115. And then, see, the question says, the angle of elevation is 60. So from this point, if we look into the top of the tree, this is 60. That's the sketch. Now we need the height of the tree. You can say let the height of the tree is equal to X or capital T or H, whatever you want. And then you can use here is suitable trigonometric functions. You can use sine theta, sine 60, cosine 60, tan 60, but some of them are easy, some are not easy. You have to choose the suitable one. Now, so we have this triangle here. The best function we can use here is tan 60, because we know tan 60 is the opposite, which is the height of the tree, capital T, divided by the adjacent, which is the distance that we have given, 115. See, tan 60 is equal T over 115. Let's cross multiply. So capital T that we need is 115 times tan 60. Now tan 60 from the table, we know it's square root of 3. I put it here in details, but you can just remember tan 60 is square root of 3. So I put here square root of 3 times 115 meters. I have to put the units. That's the answer there. Now, if you have a calculator, you can just multiply. You get 199.18 meters, approximately. Let's see another, more maybe complicated. A water tower is located 325 feet from a building. So here we have a building and we have a tower. From a window in the building, an observer notes the angle of elevation to the top of the tower is 45 degrees. And the angle of depression to the bottom of the tower is 30 degrees. So you have to read this one, I think, one or two times to see where is the angle of elevation, where is the angle of depression. And then we have to find how tall is the tower, how high is the window. Not the building, the window. So let me make this sketch now. Here we have a nice colors. So we have a water tower there. All right. And the distance is 325 feet between them. Now look here in this statement, from a window in the building. So we have a building. So there is a window here, W from the ground to the window. So we have to find that distance there. So there is an observer there. The angle of elevation to the top of the tower. So from this, we go to the top of the tower. See, this is the top of the tower, is 45. So this is the horizontal, this is the line of sight. And the angle of depression, see, this is the angle of depression here. This is 30. So this one is W. This one's the same as W here until this point. And let R be how tall is the tower here. Let's call it R. So we have now two triangles, right triangles. So I put here small ones for the colors, but this is the whole triangle. This is angle 90 and this one 325. So we start the solution now. So we take tan 30. See, the tan 30 will be the W, this one, opposite, over the adjacent 325. So W will be 325 times tan 30. Tan 30 will be square root of 3 over 3. This is the how do we find it, or you can remember it. And this is the definition for tan theta, the opposite over adjacent. All right, tan 30. So W will be, this is the window height, 325 square root of 3 divided by 3 feet. Now let's see. Let's have now, this is W, what we have found. Let's call this part here Y. And this is the, how high is the tower? This is capital R, Y plus W. So tan 45 will be the opposite over the adjacent, which is Y over 325. Cross multiply. Tan 45 is 1. We know that. Tan 45 degrees is 1. So Y will be 325. Now capital R will be W plus Y. We have seen W from this part A. This is W. 325 square root of 3 over 3. And then we add to 325. So you can take it, this is a common factor. You can write it any way you like. This is one way. R is equal to 325 bracket square root of 3 over 3 plus 1, all feet. Another one, the angle of depression from the top of a building to a point on the ground is 30 degrees. How far is the point from the bottom of the building if the building is 252 meters high? Now let's look at the sketch of example 9. Capital E, I will call it the height of the building, 252 meters here. And we have the angle of depression 30 degrees. Remember the angle of depression between the horizontal line, that's the horizontal line, from the top of the building, see now, to the point on the ground. So this is the line of sight. So that's the angle 30 there, not there. We need the distance between the point and the bottom of the building. Let's call it X. So now you have a choice here. You can use this triangle, 30 degrees. And this is the horizontal here, is this X. And this is the height E. Capital E is 252. Or you can use, we know this is 90. So if this is 30, this is 60. You can use this triangle down with 60. You get the same answer. All right. So again, I will say in the solution, I used in my solution here tan 60. But remember, 60 is this angle, not the angle of depression. Still, the angle of depression is 30. So tan 60 will be X divided by capital E. So cross multiply, x will be 252 times tan 60. We know tan 60 is square root of 3. So this is the answer. 252 square root of 3 meters is the x. Another little long question. From a point on the ground 105 feet from the base of a building, the angle of elevation to the top of the building is 30. And the angle of elevation to the top of a flagpole atop the building is 45. Find the height of the building and the length of the flagpole. All right, so please, you have to read it another time. Make sure you try to make the sketch and the solution. This is the sketch now. So we have a building. Okay. Now we have 105, the distance between the building and a point here. The angle of elevation to the top of the building is this 30, but we have a flag here on the top of the building. So this angle will be bigger, it's 45 now. So we have this triangle with angle 30 degrees and this is 90. And we have another, suppose the height of the building is capital M and the length of the flagpole is capital L. So capital L plus capital M, all this side of this triangle 45 degrees. So now let's start with the triangle that has angle 30 degrees. So tan 30 will be capital M, see this is the height of the building, divided by 105. So cross multiply, capital M will be 105 times tan 30, and we know tan 30 is square root of 3 over 3. Now we divide 105 divided by 3 is 35. So this is the feet. So this is capital M now. So from the last slide, we see that capital M, the height of the building, is 35 square root of 3 feet. Now let's take the triangle that has 45 degrees. Now we can say tan 45 will be the opposite side over the adjacent side. The opposite side to 45 degrees, capital M plus capital L, divided by 105. Cross multiply here, we get M plus L is equal 105 times tan 45 degrees. We know tan 45 degrees is 1, so M plus L will be 105. What do we need? Capital L, which is the length of the flagpole. So L will be 105 minus M. So we just write it like this, 105 minus 35 square root of 3 feet. Now, question number 11 is not easy question. Let's see that. The angle of elevation from the top of a building S to the top of a taller building, capital B, is 30 degrees. So in the first sentence here, we see that we have two buildings, let's say a short building and a high building. And the angle of elevation from the bottom of S to the top of B is alpha. It's not given, it is alpha. Such that tan alpha, 6 square root of 3 divided by 5. If the height of S is 52 meters, let's find the height of B and the distance between them. Let's make a sketch, please, or you can read it again and try your sketch. Now here, we have a building S, see, from the top of the building S to the top of the building, the angle of elevation, this one is 30 degrees. So from here is 30 degrees there. And the angle of elevation from the bottom of S, from here, is alpha to the top of capital B. This is alpha here. And we know tan alpha will be 6 square root of 3 divided by 5. Now this S is 52 meters. We have to find capital B, and we have to find the distance between them. Let's call it small d. Now this is S, this is the same as S, and then the rest of the building here, let's call it V. Okay, so let's start now with this triangle that has a 30 degrees. So this is a V and this is D. You can see that in the sketch. So tan 30 will be V divided by D, the opposite over the adjacent. And we know tan 30 will be square root of 3 over 3, or we can write also 1 over square root of 3. That's the same. This is after you rationalize. So 1 over square root of 3 is equal V divided by D. Cross multiply, D will be V square root of 3. Let's call this equation 1. Because we don't know D, we don't know V. Let's call it equation 1. Now here, let's take this triangle with alpha. This is the distance D. This is the big height, capital B, V plus S. Because we need to find another relation between D and V. So we can use equation 1 there. Okay. So we say tan alpha, this is given 6 root of 3 divided by 5, will be the opposite. The opposite will be B, capital B, all this, divided by D. We know capital B is V plus S. S is 52. So we say tan alpha is given 6 square root of 3 divided by 5 is equal V plus 52 divided by D. This is equation 2. Now let's substitute or replace equation 1, which is this one here. D equals V square root of 3. I will show you equation 1 here. This is equation 1. D equals V square root of 3. Replace it there in the D. Now we have this equation. 6 square root of 3 divided by 5 is equal V plus 52 divided by V square root of 3. Let's cross multiply. Okay, so square root of 3 is 3 times 6, 18V is equal 5V plus 260. Take 5V on the other side, subtract. So 13V is equal to 260 divided by 13V will be 20 meters. Now let's find the height of the taller building B. B is V plus 52. We found V, so that will be 20 plus 52 is 72 meters. The distance between them is small d. V times square root of 3. We already found 20, so the distance between the two buildings is 20 square root of 3 meters. Now here are some questions to practice. These questions are related to lectures 11 and 12. Question number 1, let beta be an acute angle such that secant beta 3 over 2. Find the value of cosecant beta times cotan beta plus cosine beta. Question number 2 is similar. Theta is an angle in quadrant 2 such that cosecant theta 3 over 2. Find the value of cotan squared theta minus secant theta times tan theta. Question number 3 is a little tricky. Evaluate the expression without using a calculator. We have sine 30 all squared plus cosine 30 all squared divided by cosine squared 30 plus cosine 30 squared. Figure out and try to see the trick inside. Question number 4, we have two small triangles, right triangles in a big triangle. Find the value of x, all this x. This is angle 60, angle 30, and this side is 100. Now this is an application. We have a swimmer and we have a lifeguard seat. The height of it is 375 centimeters. Please try to read it and make a little sketch. Number 6, question number 6 also, there is a tree and a man, and we need to know the height of the tree. The last question is number 7. Without using calculator, find the value of the expression sine pi over 3 times tan pi over 6 minus cosecant pi over 4 all squared. Now, as usual, these are the answers of the 7 questions. Please, for complete solutions, you can visit the video Trigonometry of Right Triangles, lectures 11 and 12, pre-calculus, all the exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you very much. Just to remind you, this is Pre-Calculus course, lecture number 12. Thank you again.